You know, some of the most beautiful shapes in geometry aren't really invented, they're discovered. And today, we're diving into one of them, a mysterious shape that seems to flow and dance, all while being perfectly, mathematically defined. All right, take a look at this. It's not a sphere, it's not quite a cone, but man, it just looks like it was born to move, right? It's got this incredibly smooth, continuous surface. So what do you think this is? It feels both super simple and amazingly complex all at the same time.
Well, this beautiful object is called an oloid, and that name brings us right into our first section, a curious rolling shape. Because really, its most captivating feature is, without a doubt, the totally unique way it moves.
So, you know how a sphere spins on a single point, right? And a cone just kind of rolls around in a circle. Well, the oloid is completely different. It has this special, almost wobbly, meandering roll. And what's really amazing is that as it rolls, its entire surface eventually makes contact with the ground. It's a completely different kind of motion. So, where on earth does a strange shape like this even come from?
You'd probably think a shape this unique would need some super complex formula to describe it. But the truth? Well, it's elegantly simple. In fact, as we're about to see, it's made from two circles.
Okay, so let's walk through this. It's actually pretty easy to visualize. First, you take two identical circles. Then, you place them so that the center of each one is sitting right on the edge of the other. And for the final step, you just tilt them so they're at a perfect 90-degree angle to each other. The oloid is simply the shape that envelops both of those circles like a tight skin stretched over them.
And this picture shows it perfectly. You can see those two original circles set at right angles. The oloid is just the surface that connects them. In math, this is called their convex hull. Think of it like stretching a rubber sheet as tightly as you possibly can around those two circles. That's it. All that graceful curvature comes from that one simple relationship. And what's just mind-blowing is how this simplicity carries over into the digital world. I mean, look at this. This is basically all the code you need to generate an oloid in 3D modeling software. You don't need these long, complicated equations. You just tell the computer, make two circles, put them at a right angle, and then generate the hull around them. A few simple commands, and you get this stunningly complex form. But here's my favorite part of this whole story. The oloid wasn't created by someone who was trying to design a new shape from two circles. Nope. It was discovered completely by accident. It was discovered by a guy named Paul Schatz back in the 1930s. And he wasn't looking for new rolling shapes or anything with curves. He was fascinated by the most basic, rigid shape you can imagine, the cube. And this is where the story takes a really wild turn.
You see, Schatz was exploring this really wild kind of mind-bending idea. He was wondering if it was possible for a solid, blocky cube to somehow turn itself inside out. He started with a standard cube, right? But then he figured out this clever way to conceptually slice it up and then hinge the pieces back together. He transformed this rigid object into a flexible, moving chain that he could join into a ring.
And this is what he came up with, the evertable cube. It's a closed loop made from the guts of a cube, but unlike a cube, it is not static at all. This ring can move, it can flow, and it can continuously turn itself inside out without ever breaking or tearing. And the way it moves is just mesmerizing. It's this rhythmic, almost breathing motion as the different parts of the original cube fold through the center. It's like a mechanical dance. Schatz had basically unlocked a hidden dynamic potential that was inside the static form of a cube all along. Okay, so that brings us to the big finale here, a shape born from motion. We're about to connect this incredible kinetic sculpture right back to our original mysterious shape, the oloid. So, what on earth does this mesmerizing cube dance have to do with our mysterious oloid? I mean, one is all sharp angles and hinges, and the other is all smooth curves. They seem like total opposites, right? Well, the secret is found by tracking a specific part of the cube as it moves. Imagine the longest possible line you can draw inside a cube, from one corner to the absolute opposite corner. That's its main, or long diagonal. As the cube ring turns itself inside out, that diagonal line is swept through space. And here it is. This is the moment it all clicks together. As the ever-tottable cube performs its dance, the path traced by its expanding and contracting long diagonal perfectly defines the shape of the oloid. The oloid is literally a ghost of the cube's motion, the three-dimensional volume carved out by that movement.
So when you look at an oloid, you're not just seeing a shape defined by two simple circles. You're also seeing the frozen, captured rhythm of a cube turning itself inside out. It's this profound connection where a simple static form holds the memory of a complex, dynamic movement.
It really makes you think, doesn't it? I mean, if a shape is wild and beautiful as the Oloid was hiding inside the humble cube this whole time, just waiting for someone like Paul Schatz to find it, what other secrets are lying dormant in the simple geometric forms all around us, just waiting to be discovered?